Hi, in this tutorial we are going to solve a question related to hydrogen NMR spectrum. The question asks, predict the splitting pattern of each kind of hydrogen for the following compound in its hydrogen spectrum or proton spectrum, proton NMR spectrum. Let's look at the molecule, and the first thing in this type of questions that you have to do is to determine different type of hydrogens. Since the molecule is given in skeletal structure, we have to explicitly show different hydrogens on the structure. Let's start. So here this is a ketone. Let's start from this side of ketone. Let's look at, we have here a primary carbon, and on this primary carbon we have three hydrogens. Let's write them H, H, and H. Next to this primary carbon we have here a secondary carbon which has two hydrogens connected, and the next carbon is a ketone or carbonyl carbon. It doesn't have any hydrogen, and the next following carbon is actually a tertiary, because it has 1, 2, 3 neighboring carbon, and it has only one hydrogen. Let's write here. And the other two carbons, they are primary carbons. Again, they have three hydrogens. Okay, after writing the hydrogens explicitly in the structure, let's start like guessing or predicting what type of splitting we might observe for those particular hydrogens. But before starting that, let's label these different type of hydrogens. So since we have here three hydrogens, they are chemically equivalent. We can call them homotopic hydrogens. Let's call them A, or let's label them A. Since they should appear as a unique one peak in NMR spectrum, hydrogen NMR spectrum. The next carbon has two hydrogens, and these are they can be enantiotopic, because when we change one of the hydrogen with something else, this carbon is going to be a chiral center, and since this is a prochirality center, we can call them enantiotopic hydrogens. But we need to consider one more factor, or we have to check whether we have a real chiral center or not in the molecule. If you check here, no chiral center, no chiral center, no chiral center. So basically these two hydrogens are enantiotopic hydrogens, so they have to appear as one peak together. So I will label them B. And here I have one hydrogen. I have to say it's just C, and methyl or primary. So since they are like symmetric, we can call them same type of hydrogens. They are homotopic or equivalent hydrogens. So I will say D and D. So they will not appear as two different peaks in the spectrum. Okay, let's look at A, and we have to find how many neighboring proton it has. Then we have to use +1 rule, because if this has n neighboring equivalent hydrogen, the splitting will be n+1. The pattern will be this way. So let's write here A. Since A has two neighboring equivalent hydrogens, the splitting pattern of A is going to be 2 + 1, so it's going to be a triplet. Okay, let's look at protons at B. Since B has three neighboring equivalent hydrogens, 3 + 1 is 4, so B will appear as quartet. let's write here. So like 4 peaks will appear for B. Let's go to C and let's look at how many, or let's find how many equivalent hydrogens in the neighboring carbon we have. We have here 3 hydrogens. We have here 3 hydrogens. They are equivalent, these 3 and these 3. So we have 6 equivalent hydrogens. So 6 plus 1, 7. So the peak for C, for hydrogen at C position, will split into 7. So we will say it's septet. Okay, 7 peaks we are expecting for C. Then last one, D. Let's look at, so this one, this set and this set, since are equivalent, we just use one of them to see the, or to check the splitting patterns. Since these 3 hydrogens, or these 3 hydrogens, they have just one neighboring hydrogen, proton, they will appear as 1 plus 1 is 2 doublet. Okay, so we solve this question based on how many neighboring equivalent proton we have. Then we decided their splitting pattern. Thank you very much for watching this video.